Hi everyone. In class, if you recall, we discussed and reviewed some of the fundamental trigonometric identities. So I'm just going to go over those again one more time and then introduce you to a few more. So first we discussed the reciprocal identities. Here are all of the reciprocal identities that you should be aware of. We have sine is equal to 1 over cosecant, cosine is equal to 1 over secant, tangent is equal to 1 over cotangent, and then vice versa. The other identities that we discussed are the quotient identities. Tangent is equal to sine over cosine, cotangent is equal to cosine over sine. And lastly, in class we reviewed the Pythagorean identities. So these are very important identities. The Pythagorean identities come from this right triangle shown to the right here. Using Pythagorean theorem, sine squared plus cosine squared would equal 1 squared, or just 1. So quickly recapping what we talked about in class, if you take sine squared plus cosine squared equals 1, divide everything by sine squared, you get 1 plus tangent squared equals secant squared. Dividing everything by cosine squared gives us 1 plus cotangent squared equals cosecant squared. So now I'm going to introduce you to a couple other things. First of all, we can rewrite the Pythagorean identities in an alternative way. If we want to, we can take the square root of both sides and write this in radical form. So here's an example of how we could write sine using the Pythagorean identity in a radical form. It would be sine is equal to the positive or negative square root of 1 minus cosine squared. Now could you do the same for tangent? Using the Pythagorean identity 1 plus tangent squared equals secant squared, if we subtract 1 on both sides, we get tangent squared equals secant squared minus 1. So to solve for tangent, we take the square root of both sides and get tangent is equal to the positive or negative square root of secant squared minus 1. Okay, you could do this for the other trig functions as well. And moving right along, I want to recall the shape of the sine graph, or what it looks like starting at 0, and how we would get to the cosine graph by doing a simple shift. If you recall from the spaghetti graphs that we did, if I simply take this sine wave and I shift it 90 degrees, moving this 90 degrees or pi over 2 units, we end up with the cosine wave starting at 0. So this gives us the cosine graph. Okay, so what would a shift of 90 degrees or pi over 2 look like if we wrote that in function form? Remember, that's just adding or subtracting pi over 2 within the parentheses. So this actually gives us another identity. These are called the cofunction identities. So if I were to take that sine graph and add or subtract pi over 2 within the parentheses, I end up with cosine. Similarly, if I have the cosine wave and I add or subtract pi over 2 here within the parentheses, I'm going to end up with my sine wave. We haven't looked at the graphs of the other trig functions, but they also have cofunction identities with their graphs. So here are all of the cofunction identities for your notebook. Last but not least, we're going to talk about even and odd identities, and this comes from whether or not the function is even or odd. So first of all, we have sine, and the sine function is an odd function, which means sine of negative u is equal to negative sine of u. The same goes for its reciprocal, cosecant. Cosecant of negative u equals negative cosecant u. Similarly, tangent is an odd function, which means tangent of negative u equals negative tangent u, and the same thing goes for its reciprocal. These are odd functions because if you remember from last semester, what defines an odd function? Well, that's simply if we have a negative input, f of negative x, the output will equal negative f of x. That leaves us with cosine and its reciprocal, and these are even functions. So cosine of negative u is equal to cosine of u. Similarly, secant of negative u is equal to secant u. These are even because the definition of an even function is if we put a negative input in we're going to get back the original output, f of x. That's it for this video. We'll practice using these fundamental identities next time. Thanks for watching.